happen at all. And the real estate in a browser is so expensive. You know, the little padlock was hard enough to get in there, right? And turning the bar green was I mean, that was a lot of pixels that we got. But I think that it has been a mistake that people who've been involved in computer security have made from the very beginning, and that perfect has always stood in the way of good. And a lot of good technologies were never implemented, or never, good ideas were never achieved because it was just too doggone hard to do. And I think if we have learned nothing over the last 25 years, we should have learned that if we don't make security seamless to the user, and that the user doesn't have to think about it, it just happens. And that's the best part of the DNS aspect of this, is that so much of it happens in the background and is done automatically that the user doesn't have to engage with. And I think we need to build on that and do as much as we can around securing the infrastructure and securing the transactions that the user never has to interact with. They just know when it's not working, and it's going to work, and it's going to work well most of the time. And that's where, you know, the challenge, I think, to the industry is, yeah, we've got a lot of, look, crypto algorithms are good and easy to come up with, but I tell you, if you ask every user to start generating keys and stuff like that to do SSL transactions, it would never have happened. I mean, we'd still be, I mean, usernames and passwords are at least 15 years out of date, okay, 10 for sure, but somehow end users have never wanted to adopt a tougher technology because we haven't made it easy enough for them to do that.
Anybody else wants to answer this? We are
genie's out of the bottle. Let's do it. Let's build it. That's great. Yeah. Perfect.
We certainly are looking forward to demo versions of dense software. Very exciting. Yeah. Next question.
So the root key is obviously physically protected. What protections do we have against crypto attacks when our attackers can have a botnet of 100,000 computers or more, or anyone with the financial incentives, say governments, that have the kind of power, the massive server stacks to try and generate a collision against your hash, or, you know, just a crypto attack against your root key? Will it be changed every so often, or is it just a very long key length? What do we have going on here?
It's both.
It's all of those.
Yeah. So, Dr.
You could do an answer too.
Dr. Lam, could you?
Oh, it's an RSA 2048-bit key. We have plans, no specific plans, but plans to roll it somewhere between 2 to 5 years. Currently, a lot of the crypto experts, I would hope that Wood was around here, or maybe some of his pals were around here, but that's considered a pretty reasonable time for 2048-bit keys. So, you know, we do have a rollover mechanism that we hope we don't have to ever use. But again, you know, if there's some report in the crypto world that says that we can roll the key and do that hopefully seamlessly over the next, in a few years. Right now it's a very manual process, but there are automated mechanisms that the IETF, you know, who developed the DNSSec protocol, is also trying to press forward.
One quick follow-up. Do we have a key revocation protocol? If it is compromised, can that key be invalidated immediately?
Yes, we do. We have a process for that. There was a fair amount of discussion about what key sizes would be used based on what devices and what compute horsepower would be available to the systems that were querying it. So the key length is sufficiently strong to survive good attacks, and thus far that key length has not been cracked. But we expect people will try. We fully expect that they will try, and that's why we've used tried and true algorithms, which have been under attack for a number of years. Specifically, we use the latest hashing algorithms so that those are sufficiently secure today. But there is a protocol in place that should the key ever become compromised, that there is a process in place for revoking it and replacing that key.
Thank you.
Maybe he wants to speak.
Yes?
Well, I think it's not only the root key that is in that situation. It's the keys for everybody. I mean, there are established rollover scenarios, and there's also established protocol or at least conventions for trying to minimize the the amount of communication that you have with your parent zones in order to update the signatures on your individual records. Say that if people are coming after you, and for example, you wanted to use a shorter key length. So.
Just as a note, in X509 we talk about revocation. We think we have revocation. You look at everything that's supposed to implement revocation, and it always turns it off because the performance is terrible. In DNSSec, you're looking stuff up anyway. That's kind of the point. Here's the deal. In X509, no one wants to say my website goes down if VeriSign servers goes down. Sorry, but that's the truth. And so we end up with everything turns off revocation checking, except for EV where it's contractually obligated. In DNSSec, if your name server goes down in your operations center, you know what, that's on you. You're kind of okay with your web server going down too. And so we have this really interesting situation where in DNSSec, you can have revocation. You actually kind of get it for free because you're always refreshing your key material. And so revocation becomes as simple as the next time you refresh your key material, there's a new key there. It's effectively for free.
Well, I don't know that I agree that everything turns off revocation. I mean, we're getting currently 2 billion revocation checks a day just for our certificates. So I think that's a pretty substantial number. But I don't disagree that some systems do turn it off because it does hurt the performance.
At the point where there's 2 billion, okay, not everything turns it off. That is correct.
One follow-up just to that last question. I mean, would you like to
address
it?
Please, go ahead.
Is that there are actually 2 keys in DNSSec. There's this top root key, that's 204 8-bit. That signs another 1024-bit key that gets rolled 4 times a year. So that gets changed very frequently. Just thought I'd throw that in there.
Next question, please.
Now that you've fixed DNS, what's the next fundamental part of the internet that you're going to fix?
Netware.
BGP. BGP is next on my list.
Since we are running out of IP spaces, perhaps we will fix the IPv6. Not that we will fix, but we will all move on to IPv6, I guess.
Well, there's also the whole routing structure. I mean, all we've done.
Security and routing.
Right. I mean, all we've done is, taken this one small little phone book part here and trying to secure that. I mean, there's this whole set of IP addresses and routing tables, and that's something called RPKI, and there are a number of people working on it. There are always some policy issues with things like this. The technology is there. People have developed a lot of protocols on it, and I recommend you see some of the IETF things under their CIDR group, SIDR.
But I think with the routing infrastructure and BGP in particular, it presents an interesting challenge because the entire internet has relied upon that infrastructure operating in exactly the way that it operates today. To begin to add security to that, every router on the internet has to implement it or it doesn't work. And so the challenge that we have today is that it's not difficult for someone in Pakistan to redirect youtube.com to Pakistan because today it relies on really a handshake and a slap on the back that says, okay, only this AS can announce this address block. And it's only if the ISPs actually enforce it, and not all of them actually enforce it and validate that in fact that AS is authorized to announce that space. So until we have some security around that, whether that's a signed BGP announcement or whatever it is, and there are a number of standards that are being worked, it's going to involve the entire internet community and ISP community to implement that change. So that's not going to happen suddenly, but thankfully the work's being done today that's laying the foundation for that.
Perhaps not the example you gave, but like the web forwarding kind of issues, which similar things has happened in China with one of the root servers and made news, so you probably heard, like forwarding the IP address or forwarding the resolver to a different IP address. What exactly happened in China was that iRoot was suddenly resolving to facebook.com, which was very interesting within China, within a small region, and it was actually detected by some community in Chile, in South America, and this made a big news. And these kind of things obviously will be avoided when DNSSec is implemented, because it will just not work. It will just not resolve.
So you were talking about before how part of the beauty of DNSSec is that it can be doing the validation in the background, the user doesn't need to worry about it. But aren't we quite a ways off from that? I mean, until everybody starts signing their DNS records, I don't see a lot of pressure to kind of move people to start doing that because it's sort of like it works right now, as far as most people are concerned. So don't we have to have like client support for doing things like similar things to like the padlock, so that those people who do start implementing this, it'll show up and we can start distinguishing, oh, this is more secure than this, push people to implement it. And is there, I haven't seen that in any clients as of now, is there any movement in that area?
Well, I think there's three things that have to happen, right? You have to get the domain signed, and that's one of the reasons why signing the root is sort of important, because it's kind of a chicken and egg problem. If you don't have signing happening, then there's not going to be any incentive for clients or ISPs to actually turn on the validation in their infrastructures. So they have to believe that it's become important. And I think, and that process is ongoing, because if you go to the average ISP and tell them, hey, turn on DNSSec validation today, right? They're going to go like, why should I do that? That's just going to cost me in terms of infrastructure, and what do I get economically out of that? So that's been one of the historic, issues, problems, et cetera, beyond just getting the signing infrastructure going. So getting the signing infrastructure is first, the resolving infrastructure is second. I think the point of Dan's talk 2 days ago was basically, well, it'll be great if we can get it across all of these large infrastructures, but let's start looking at applications that can actually do things on the client sooner rather than later, and trying to, with the various prototypes and so forth that he showed, where maybe not everything is figured out, but hey, it's not as hard, I think the point he's trying to make is it's not as hard as it might be. So let's get some applications going, and that will convince the rest of the resolving community to go ahead and deploy DNSSec.
Thank you.
Are there any bright spots in that right now? Any like Firefox extensions or anything? That,
yes, there are some add-ons that you can download for Firefox that would validate against DNSSec, and that would actually show a green light if DNSSec validation is correct.
And does that require your DNS infrastructure to be handling that, or is that handled from the plugin?
Well, obviously.
End to end or go home.
What's that?
End-to-end secure, or you're not doing enough. That is the bar that we have as a community, and though DNSSec has a lot of support for looking at your resolver, making sure the resolver has it, there's tremendous value to DNS resolution itself, making sure the resolvers are not cache poisoned. That's what the technology was originally designed to do. What we deployed 2 years ago was a Band-Aid, and correct cryptographic data for just normal records. DNSSec fixes that. But it's a steamroller for a bug. The value comes from being able to get all these certificates for recognizing websites, for recognizing emails, for being able to log into SSH servers. This is where this stuff gets particularly valuable. And seriously, we're going to show just how easy it is to patch DNSSec support into applications. At the end of the day, I've probably spent 10 times as much time making the rest of the app realize it can actually trust DNS than actually doing any sort of hard DNS work. It's kind of cool.
Thank you.
I am gonna close the mic, and answers should be limited to 2 minutes.
So last question then. Dan, you were talking about how passwords, username passwords, been obsolete 10, 15 years. Is there any thought to maybe getting Microsoft, Apple, the other OS companies on board, having some sort of public key infrastructure for the users, maybe smart card with every laptop, something like that, and authenticating the users via DNSSec?
So we refer to this as the domain key infrastructure. One of the things that actually we haven't implemented yet, So we have a preload library for OpenSSL that takes every OpenSSL application and makes it just immediately work with DNSSec. No code modifications whatsoever. Where this is cool is you can run this against Apache, and suddenly Apache client certificate checking inherits DNSSec. Now, the challenge is